Okay, so the goal in the next section is to study ODEs of the following form, namely first order ones, ODE of the form y prime equals any function of y and t. So it doesn't have to be linear necessarily, because for instance, y prime equals to t y squared plus t cubed is of this form as well. And what I'll show you now is how to do a qualitative study of an ODE. Qualitative study, which is how to get info about the ODE without actually solving it. About the ODE without solving. Why? Because the truth is, a lot of ODEs we cannot solve them explicitly. And in fact, in your adult life or post-university life, you will see a lot of ODEs won't really have explicit solutions like that. Yet, we can still study them qualitatively and get interesting info about those. Think, for instance, the stock market, where you can't exactly find a solution to its behavior, but you can still sort of approximately study it. And one very nice way of doing is using what's called a direction field. In fact, it's a nice way of visualizing ODE. Visualizing solutions of ODE. ODE. So, in fact, let's do just that. So let's draw or plot the direction field. Direction field of y prime equals y plus 2. And what's interesting about this ODE is you can actually solve it explicitly. And the cool thing is then we can actually compare how our drawing compares to the actual solution. And what's the idea behind a direction field? Well, remember a derivative. That's just the slope of a tangent line. Slope, tangent line. So if you have a function y like this, remember y prime tells you which direction the function is going. Y prime literally gives you the slope of the tangent line. So in particular, what does this equation say geometrically? Well, y prime equals y plus 2. This just says that the slope, or the way the function curves, is just the value of the function plus 2. So, for instance, if y equals 0, then this tells us that y prime is y plus 2, which is 0 plus 2, and that's 2. So whenever the function is 0, so kind of on the x-axis, the function always curves 2 units up. Or similarly, if y equals 1, then y prime is 1 plus 2, which is 3. So whenever the function is equal to 1, its slope is 3. And using that information, value and slope, we can actually draw a rough picture of what the solutions look like in the following way. So on the left-hand side, I'll draw a table with value and slope. And on the right-hand side, I will draw actually the graph based on the info that we've. So one thing that we saw, if y equals 0, then the slope is 2. So based on what I said, y equals 0, here is the x-axis. And on this whole line, the function goes up 2 units. Kind of like this. And by the way, so the axes here are t and y, if you want. This is t and this is y. Well, we can continue. Well, we've seen that if y equals 1, then y prime would be 3, which is even steeper. So maybe the picture looks like that. That's for y equals 1. If y is 2, then it's even steeper. Y prime would be 4. So maybe it looks something like that. That's for y equals 2. All right, on the other hand, let's go down a bit. So if y is minus 1, then y prime is minus 1 plus 2, which is 1. And that is a bit less steep. So maybe it looks like that. That's for y equals minus 1. And well, what's interesting is for y equals minus 2, then y prime would be 0, which is actually horizontal. Y equals 0. And of course, we can go down even further. We can do y equals minus 3. And then y prime would be minus 1, which are just arrows going down. Let's see, orange. Once. And well, you can do further. Oh, sorry, that should be y equals minus 2. Minus 2, and then that's for minus 3. And then for y equals minus 4, it would go down even more like this. And the cool thing is, well, now we sort of get an idea what the solutions look like. So if you give me any initial condition, let's say here, maybe, you just need to follow the arrows. So the solution that goes with this initial condition might look like that. Why? But we can do more. If you want a solution that starts here, might look like that. Or if solutions, you want it to start here, in this case, it curves down. In fact, just by connecting the arrows, you can already see that the solution looks exponential. So kind of the finding. Solutions look exponential. Without even solving it. And in fact, here's the cool thing that I mentioned at the beginning. You can actually solve this ODE explicitly. And if you find, if you do that, you do find that the solutions are in fact exponential. Because if you solve y prime equals y plus 2, you get y is ce to the t. minus 2, which in fact agrees with this picture. But what is the whole point? We did that without solving the ODE, which is why it's a qualitative method, extracting info out of the ODE without solving it. And of course, as you may guess, this really works for any first order ODE of this form. You can also have a t in it, which means the more right you move, the slopes can be different as well. That's it. Good news. Usually we won't do this by hand. We will do this on a computer, which is the point of the next video.